Okay, students, welcome back. No, I'm just fucking kidding. All right. Okay. Yeah. um. All right. I'm gonna show you. So this was it was called. Oof. It was the third thing because I'm working backwards. Sulfonation reaction, and then I wrote like a little note in parentheses. Involvement of SO3. Okay. So what this means is, well, first of all, you always start out with the benzene. Start out with benzene. Now we start out with benzene because, oh, a reminder. Oh yeah, cool. Okay, you start out with the benzene because you, honestly, we're working with what are they called? Aromatics, aromaticity, whatever it is. And he said you start out with the benzene, and dang it, there we go. There we go. Sorry. Anyways, you start out with the benzene. Oof. And you always have this like hydrogen, right? Color code, color code. Guys, I color code for you. Okay. Anyways. And you have your reagent and your, I'm assuming solvent because he did this. And I just assume this is solvent. Okay. So basically the product is going to be this. Of course, we have our electrons. You must write your electrons because you want to keep track of your electrons. Okay, I don't sound like him. Anyways, so yeah, and then he said, like, these resonance resonant contributors. Like, what are how many resonant contributors? And people are like 3 because I have it on the recording, and I know there's 3, and it says a resonance hybrids, and I'm assuming it's the drawing I'm going to draw for you later. So for now, I'm going to write A is resonance contributors, and B resonance hybrids, or hybrid. I'm just going to do this. Anyways, so if you start with letter A, so you have your H, right? Your hydrogen, and basically you have a pi donor right here. So what this does essentially is, and you have your molecule, right? And here it's an empty space because sulfur is a positive. Right? Okay. So basically, in the middle of the pi bond, it attacks that. Ew. Okay. And, of course, you have to have your counter ion. Okay. Now here's the most important part. Resonant contributors, or resonance contributors. I don't know how to say it right. But anyways. Here we go. Okay, so you have 3, and you know that you have 3 because he said you have 3. Basically, hold on. Okay, so oh shit. Okay, I'm sorry. I just caught myself. We no longer have this pi bond, right? Because we donated it. So, okay, here we go. Honestly, at this point, I'm just going to do this. Okay, and we have a carbocation here, right? Okay, cool. So, when we start off, because we have to draw resonance contributors, we draw the resonance structures. So that goes there, right? And what does that look like? So the carbocation moves over here, and we draw the pi bond right there, right? Because it resonated. Now we do it again because the resonance structure continues. Oh, FYI, just a little tip, or not a tip, a comment that's really important. This structure, I'll do it in a different color. I'm a color code, green. So we have this and this, right? It's allelic. Haha, Chem 333. Anyways, okay. Ah, dang it. Okay, anyways, back to this. So yeah, it jumps, right? You have these resonating. So that's another one. And then we have, so this one moved over here. Wait, yeah. And then that carbocation moved up here. And that's, hold on, I need to choose. I'm sorry. I'm trying to do this super duper fast. I'm usually faster, but I want to make it look neat for you. So yeah, we have this. Oh, and he said, don't forget about adding your counter ion. So yeah, so we have these three. If you notice, the carbocation is secondary carbon, another secondary carbon degrees, and then the other one is a secondary carbon degrees, right? Cool. And now that we have that, okay, now I'm gonna like shrink it and put it in here. Now that we have that, great, we can continue, but we have to draw the product. But before we draw the product, we have to do a beta deprotonation. Now that basically is, we look at this one, okay? I'm just going to duplicate it and put it over here. I'm going to do it in green. This hydrogen, it's going to come right over here and form a double bond. So then what that looks like, I'm just going to hide this guy over here, okay? What that looks like is a benzene ring with your reagent attached to it. And this is the final product. I mean, I don't have to, well, yeah, the hydrogen is no longer there because it became that bond. So yeah, this is your product. This is the answer for A, which I'm like 99% sure. That's what he's talking about, resonance contributors. And then, oh, my bad, this is not this necessarily isn't your answer, like for letter A, so I should say this is letter A. This is just your product. And then for B, resonance hybrid, I'm just writing fast now because I think you're getting bored. Would it be like this, where you have essentially where all the pi bonds jumped, it becomes like hybridized. So you form that, and of course you have your sulfite, I think it's called, or hydro. I don't know what this is exactly called, but anyways, you have this formed, which is your resonance hybrid. Yeah, and your product. Okay. I was gonna say something, but I forgot. Anyways, yeah, that's it. That I get it, and that's the answer. I mean, if you want to see the answer, check this out. Watch. If you don't believe me, if you're like, oh my gosh, are you sure? Are you sure? Well, yeah, cause look, you have this. You got this, and your product turns out to be like that. You see, I know I got it right. Ignore this. He was just telling us how, how do I explain it? How this, I don't know how to explain it, but just don't worry about this. He was just showing us the mechanism of this becoming that. I hope that makes sense. Anyways, yeah, here you go.